Good day everyone. Welcome back to JBS Wiki, your go-to destination for all things SQL Server. Today we are diving deep into a topic that can make or break your SQL Server performance, cardinality estimates. SQL Server's query optimizer is like the maestro of a symphony, conducting the most efficient orchestra of data retrieval. And at the heart of this intricate performance lies cardinality estimates, the crucial numbers that guide SQL Server in crafting the perfect query execution plan. But what happens when these cardinality estimates go rogue? When they don't accurately reflect your data anymore? Well, my friends, that's when the problem begins. Outdated cardinality estimates can lead to suboptimal execution plans, slowing down your SQL server and leaving you scratching your head. But fret not, because today we are going to uncover the secrets of taming these estimates. I will show you practical steps, real-world examples, and expert tips on how to update your statistics, rescue those pesky cardinality estimates, and reclaim your SQL server's peak performance. So, whether you are a seasoned SQL pro or just starting your database journey, this video is packed with valuable insights and can make your SQL server sing like a well-tuned symphony. Stick around because by end of this, you will be a cardinality estimate maestro. But before we dive in, do me a favor, hit that subscribe button, give us a thumbs up and ring that notification bell so you never miss an episode. Your support means the world to us and this keeps our channel going strong. All right, get ready to master SQL Server query performance as we embark on this journey to tame those cardinality estimates. Let's get started. In this video, we will talk about selectivity. We will discuss how do we calculate selectivity, when and where selectivity will be utilized by the query optimizer as far as estimates are concerned. And we'll talk about estimates when we have outdated EQ rows on the histogram steps, and also the effects of updating the statistics. We'll be using a database, AdventureWorks DW, for this demo as well. As far as selectivity is concerned, it is calculated by dividing the number of rows based on the particular predicate divided by total number of rows on that particular table. So in our case, let's consider we have a table called table 1 and it has got close to 10 rows, and in order to calculate the selectivity for a query, select star from table 1 where predicate is equal to some value. The selectivity is calculated by dividing this particular query with the predicate divided by the total number of rows on object table 1. So in our case, let's check the selectivity value for this particular query, wherein what I will do is like I will divide this query, which is select count star from or table 1, and the predicate is on column 4 and the value is 11 January 2024, 8:32 p.m. 6 seconds. So this is the query. So I have put that query and I divide it by count star of table 1. That is a total number of rows present on that particular query. Let's look at the selectivity value. And what I'm seeing is like the selectivity value is 0.073. That's the selectivity value. Yep. So now what I'll do is like I will ensure that the actual execution plan is disabled, and then I will try to insert close to 5,000 rows onto this particular table. Yep. So if you see here, what I'm basically doing is like I'm trying to insert 5,000 rows on table 1, and the values will all be same for all the columns except column 1, because column 1 is your identity column on the table. Yep. So I will execute this query. So it has inserted close to 5,000 rows. So now what I'll do is like I will execute this query with the execution plan. So this query is trying to find the number of rows on table 1 with predicate column 4 is equal to 11 January 2024, 8:32 p.m. 6 seconds. So let's execute that query. And I'm seeing a row count of 13,000. That is like I have 13,000 rows with this predicate. So let me go to the execution plan and then look at the cluster index scan that is happening on the table one. So we have a cluster index scan on table one. So let's look at it. And the estimated number of rows here is like 3290.62. So that's the estimate here. So let me note it down. So let's look at it again. It is 3290.62. Now let's see from where we got this value. So now I'm going to execute this query and then get the statistics for column 4. So as far as column 4 is concerned, this is the statistics value. Uh, so what I'm going to do is like I'm going to replace this one with whatever I have picked it up. Okay, I'm going to execute this query, dbcc show statistics, table name, statistics name. So if you see here, this is the statistics that is present on column 4. So let me execute that. And then now what I'll do is like I will check the histogram step for value 11 January 2024, 8:32 p.m. So if I look at it here, what I'm able to see is like I'm able to see that I have a direct hit on the histogram, which is basically 11 January 2024, 8:32 p.m. That's same here. Yeah, both are same here. But we are not using the EQ rows here. It is a direct hit as far as the histogram is concerned. If you look at it here, the histogram step is same as the predicate that we are using here. Yep, and also the query that I'm using here, it is all same. So if you see here, column 4 is equal to this value, and this value is same as what we have in the histogram step. The thing is like SQL Server Optimizer will not use the EQ rows for from the histogram step if it knows like there are major changes after the time the last update statistics happen on the table. For example, if Optimizer knows that the statistics are not up to date, then what it basically does is like it will not use the EQ rows or it will not use the average range rows. Instead, what it will do is like it will basically use the selectivity. In our case, we clearly know that we inserted close to 5,000 rows on to this particular table, and Optimizer keeps track of these changes after the last update statistics using the row modification counter, and then it clearly knows like if there were any changes. And for example, if these changes are like above its threshold value, then it doesn't use the EQ rows or average range rows. For example, if the value is buried between the predicate, it uses the average range rows, and if it is a direct hit, then it uses the EQ rows. In case if there are changes after the last update statistics which is above its threshold, then what it basically does is like it will calculate the selectivity value, and then it comes up with the estimate. So in our case, we know that for this there is a direct hit on the histogram, and the EQ rows is 3,000. So let me pick that up and put it here, and then we know like we have this many number of rows on the table when the statistics was last updated. So we will put that here. Let's divide the EQ rows and the table count, and whatever value we have here, we will put it here. And then what we'll do is like we will multiply the selectivity value with the total number of rows that is present in the object. So the difference here, so what we are doing is like we are first calculating the selectivity, and then we are multiplying the selectivity value with the number of rows present in the table one. So selectivity is calculated by putting in the EQ rows as far as this particular histogram step is concerned, which is a direct hit to the predicate that we are using. Here it is 3,000, and then the total number of rows as far as the show statistics command is this. So we are putting that, and we are calculating it. We are calculating selectivity value, and we are using this selectivity value and multiplying that with the number of rows present on table 1. So now if I execute it, what I'm seeing is like the value here is 3290.62, which is same as what we got as far as the estimate is concerned. So what we'll do is like we will copy that, and then we will execute that query side by side and then see that. So I've executed it. Now, if I look at this query here, it is 3290.62. That's the estimate, and the calculation that we have done is exactly same. So that is how optimizer came up with this estimated number of rows as far as this particular query is concerned. Now, looking at the execution plan, what we'll do is like we will execute this query again and then look at the cluster index scan operator. Here we are seeing the estimated number of rows as 3290.62. But the actual number of rows for all execution is like 13,000. So let's consider it as like 4 times more. Like we estimated, it is a lower estimate. Like we estimated 3290 rows, and we end up returning close to 13,000 rows. So whatever calculation the optimizer did based on the selectivity value, it is not accurate in this case. So we basically like returned 4 times more rows, and in case if it is going to be in a real-time world scenario, and in case if the number of rows is more and we do a lower estimate of 4x, then it's going to be a huge performance issue. So what we'll do now is like we will try updating the statistics with full scan, and once this is completed, what we'll do is like we will execute this query one more time. It's the same query as previous one, and we have returned 13,000 as last time. And now let's look at the estimates. This time, after the update statistics with full scan, what I'm seeing is like I'm estimating close to 13,000 rows and I'm returning close to 13,000 rows. So that's a perfect estimate. So after the update statistics, it is no longer a 4 times lower estimate. This time I'm doing a perfect estimate. So that's the power of update statistics on the tables, and for improving the performance of the query. Any performance issue, the first thing that we request is to do an update statistics, and the reason is to just to make sure like the optimizer is able to get the exact information as far as the statistics is concerned, and that way we come up with better estimates, and also the execution plan, and also your query improves. Now let's look at the query. Let's look at the statistics information. So it is on column 4. So I think let's execute this query again. We have the statistics there on the column 4. So let's execute it. And if you see here, this time what you're able to see is like after the update statistics, we are no longer seeing 3,000. We are seeing 13,000, and this is where we basically got our estimate for this query. Again, we have this 13,000. Let's execute side by side, and then look at the execution plan. We have 13,000, and then on the histograms tab, we can see 13,000 in the EQ rows, and this is how we came up with the estimate. That's it for this video. Thanks for watching. Have a great day. Jai Hind.